Hello everyone, in this video, we will be discussing how to describe the preparation of different solution from a given specific gravity in mass percent. So let's start with number one. Describe the preparation of 100 ml of 6 molar HCl from a concentrated solution that has a specific gravity of 1.18, that is 37% mass percent. So weight per weight. HCl with a given molar mass 36.5 grams per mole. Okay, so if you have seen the previous video, we have discussed about how to solve the molar concentration given the specific gravity and the mass percent. But in this case, we want to know or to describe, right? So to describe how to prepare a specific solution given the volume and the concentration. So this problem involves dilution principle. Okay, principle. If you remember dilution principle, that is just concentration 1, volume 1 is equals to concentration 2, volume 2. So C1 V1 plus C2 V2, which we will discuss later. But this is a basic principle when solving the concentration. So the basic concept here is that we get a specific volume from a concentrated solution and we prepare a diluted solution, which in this case is 6 molar with a specific volume 100 ml, and we need to describe it. Okay, the goal here is solve the volume of concentrated concentrated acid to create the specified solution. Okay, so we need to calculate for the volume. Okay, and to create the specified solution, which is the 100 ml of 6.0 molar HCl. Okay, so let's start by solving the concentration of the concentrated solution. Okay, let's start with that. So for the solution, so if you have seen the previous video, we have discussed how to do that. We start with the 37% mass percent. Okay, so that is 37 grams HCl per 100 gram solution. Okay, we have discussed this in the previous video. And let's use the molar mass. Okay, so 1 mole HCl is 36.5 grams. Okay, see here. And now like we can cancel the grams. And let's use the given specific gravity. So if you have seen the previous video, this is a unit of grams per ml, because this is approximately equal to density. So this is 1.18 grams per ml. Cancel the grams, and we are left with mole per ml. Let's our aim here is to create a unit or of mole per liter or molarity. So let's convert that to liters. Okay, and now you can solve for the molarity, which is 11.96 molar. Okay, so this is the concentration or the initial concentration of HCl. So this is the C1, the concentrated HCl. Okay, this is the concentrated form. We can assign this as C1. So with that, let's use the dilution principle C1 V1 to calculate V1 because we want to know how much volume needed for us to create the 100 ml 6 molar HCl out of the 11.96 molar concentrated HCl. Okay, so with the C1 V1 equals C2 V2, we can get V1 by dividing C1 to the C2 V2. Okay, so this is what we're going to use. So V1 is C2 is 6.0 molar and our V2 is 100 ml. So this is our final solution. And the initial concentration, which we have solved, is 11.96 molar. Okay, so with this, we can we can cancel the molar unit, leaving us with the ml unit. Okay, so that is 50.17 ml. Okay, so approximately 50 ml. So this is the volume needed in order for us to prepare the 100 ml 6 molar HCl. So we are asked to describe the preparation of the solution. Okay, so let's describe it this way. So since we have calculated the final or the initial volume needed for us to create the solution, let's say place 50 ml of concentrated HCl to a 100 ml volumetric flask. Okay, so VF, volumetric flask. Then after that, dilute to mark. Okay, after diluting to mark, you have produced the 6.0 molar HCl. Okay, so that is how you prepare the 100 ml 6 molar HCl. Okay, so for more practice, let's solve two more problems. Okay, number 2, describe the preparation of 250 ml of 1.50 molar sulfuric acid using a concentrated sulfuric acid solution that is 98% H2SO₄ weight per weight with a specific gravity of 1.5. Given the molar mass is 98.08 per. Okay, so let's start with the given specific gravity, which is 98%. So that is just the same for 98 grams H2SO4 over 100 gram solution. Okay, and we can use the molar mass of the H2SO4, 98.08 grams. So that is the 1 mole of H2SO4. Cancel the grams, and let's use the given density or specific gravity, which is 1.84. So that is in grams per ml unit. So we can cancel grams, grams. Then let's convert ml to liters. 1000 ml is 1 liter. And that would be, okay, let's cancel ml, leaving us with mole per liter. Okay, so that would be 18.38 molar. Okay, this is the concentration of the concentrated sulfuric acid. Okay, so 18.38 molar. Now let's use the dilution principle. C1 V1 equals to C2 V2. We want to find V1, so C2V2 over C1. Okay, so V1 is equal to our C2, so the concentration of we want to prepare, which is 1.50 molar, and V2, which is the volume, 250.0 ml, and our initial concentration, which is the concentration of the concentrated acid, is 18.38 molar. Okay, so let's solve for V1. That is 20.40 ml, since we can cancel molarity. Okay, so this is V1, or the volume needed for us to prepare the 250 ml 1.50 molar sulfuric acid. Now let's describe the preparation process. Okay, so as usual, it's the same. So let's place 20.40 ml concentrated, okay, concentrated sulfuric acid to a what volume metric flask, 250 ml, 250 ml VF. Then dilute to mark, then you created a 1.50 molar sulfuric acid solution. Okay, so that's it. That's very easy. So last question. Okay, describe the preparation of 500 ml of 0.750 molar nitric acid solution, that is 68% HNO₃ weight per weight with a specific gravity of 1.41. Okay, so given weight per weight percent, a specific gravity, and this is the final volume and the final concentration. Okay, so as usual, let's start with solving the initial concentration. So we have 68% nitric acid mass percent. So it is 68 grams HNO₃, okay, over 100 grams of the solution. Then let's use the molar mass of HNO₃. Okay, this time the molar mass is not given, so let us solve it ourselves. So hydrogen is 1, and nitrogen is 14, and oxygen is 16, and that is 3 oxygen, so that would be times 3. Okay, so this is our gram. So this is the molar mass of nitric acid. So we can cancel gram. Okay, you can check the periodic table. Then we are left with mole per 100 gram. Let's use the specific gravity, 1.41 gram per ml. And we can cancel that. And let's convert ml to liters. Okay, and we are left with mole nitric acid per liter. So that would be the C1, or the initial concentration of the concentrated nitric acid, which is 15.22 molar HNO₃. Okay, so this is the molar concentration of nitric acid. Okay, so this is concentrated nitric acid solution. Okay, from this, let us use the dilution principle. C1 V1 equals to C2 V2, and we want to calculate for the V1. Okay, let's use this formula. So V1 is, so what is our C2? So the final concentration should be 0.750 molar. And the final volume is 500 ml with our concentration that we have solved, 15.22 molar. Okay, so that's our C1. And let's solve this. 24.64 ml. Okay. Okay, so this is the volume of the concentrated nitric acid that we must use in order to prepare the given solution. Okay, so let's describe the preparation. Okay, so place 24.64 ml of concentrated nitric acid to a what 500 ml volumetric flask. Then dilute to mark. Then you have prepared 0.750 molar nitric acid solution. Okay, so that is how you describe the preparation and how you solve for the molar concentration of a concentrated acid by its specific gravity and mass percent. So this is usually how you solve for the concentration and how you prepare for a specific solution given that these values are in the label of your concentrated acid. Okay, so that's all. Thank you for listening and I hope you have learned from this video. Okay.